Part B, describe how copper sulfate solution is obtained from the plants used in phytomining. Copper sulfate solution. So solution, remember, is dissolved in a liquid, and the liquid we call a solvent. Okay, so how do we get the copper sulfate from those plants? It's worth 2 marks. 1, 2. And this is quite a lovely question, because if we look back at question 1, they gave us all this information. Okay, well this is the land they use, this is how they get it. Okay, there's the first reference to the plants, what they do. It involves the combustion of plants. Okay, the burning of plants. So that's obviously important. Well, it's important because that's how you get the copper sulfate from the plants. So the first thing you do is the plants are burned. So plants are burned, and then what happens is there's copper in the ash that's left behind. So then the ash contains copper, and if we can remember here, copper sulfate, to make a metal sulfates, a metal plus an acid plus a metal plus sulfuric acid will make a metal sulfate. So in this case we've got copper, we need to react it with acid. Okay, so ash contains copper, which you then dissolve in sulfuric acid. Okay, and that makes copper sulfate. Right, next one. Copper is displaced from a solution of copper sulfate using iron. Write a balanced symbol equation for this reaction, and this is worth 2 marks. So you'll write a balanced symbol equation for this reaction. So there's no point here writing the names, because that's not going to get any marks. It's got to be a symbol equation. So first thing, let's have a look at what we've got. We've got copper and copper sulfate, which is CuSO4, and we've got iron, which is Fe. Okay, so what are we going to make? Well, we're going to make copper is displaced from a solution of copper sulfate using iron. So we're going to have copper sulfate and iron are our reactants. We're going to react those together, and we're going to produce copper, and we might produce something else. So let's see. So we've got copper sulfate. So copper sulfate is SO4 plus iron, Fe, turns into copper. Plus, because there's a displacement reaction, what's happening here is the iron is swapping places, is displacing the copper. Okay, so it's swapping places with that, so we end up with iron sulfate, SO4. So if we quickly look at the sides, what have we got? We've got, so here's my, that's my reactants, so reactants. And then on this side I've got products. Let's just quickly check. So I've got Cu, got one there and one there, which is good. I've got SO4 because that moves as one whole thing. Got one on that side there, one over there, perfect. And iron, one there and one there. Excellent. So that's already balanced. So I'm happy with that. That's a balanced symbol equation for that reaction. Part D. How does this displacement reaction happen? Okay, well, okay, we've got copper is a metal. We've got sulfur and oxygen are both non-metals. Okay, so that means that must be A metal plus a non-metal means that's an ionic compound. Ionic compounds, certainly not proton transfers. We don't get proton transfer. Reactions are all about electrons. Electron sharing, that would be non-metals only. That's covalent. So we know it's not that. Ionic is metal plus non-metal, electron transfer. So it's that one. Okay, and we'll stop there, I think, for this video.